Okay, here's our 3.4 lesson on orbitals. Let's go back to the quantum mechanical of the model of the atom. So we talked about this when we talked about Schrödinger and Heisenberg back in Unit 1, and we said that there are some mathematical equations that can identify certain regions where we are most likely to find an electron. And remember the example where I said you're most likely to find me in the front of the classroom? In the same way, electrons are most likely to be found within these shapes. You don't need to know the equations. It's way more complicated, but you do need to know what these shapes are, how many there are, and how many electrons they hold. So we talked about the Heisenberg uncertainty principle, where he said you cannot simultaneously determine both the position and the momentum of an electron, where he's saying, essentially, you can find out where it is, but not where it's going, or you can find out where it's going, or how quickly it's moving, but not where it currently is. So all of our models are based off of Heisenberg here in Schrödinger. Okay, so we're going to look at orbitals, and then in extension to that, tomorrow we're going to look at electron configuration as sort of an atomic address. So for me, as you sort of narrow down, I currently live in Tennessee. I live in Donaldson. I live on a street that I will not tell you, at a house that I will not tell you, and you are most likely to find me when I am at home on the back patio. Right? So that's, if you were to come to my house and try and find me, that's most likely where you would find me. In the same way, when we're looking at an electron and its position around the atom, we know that it's in a certain atom. We know that it's in an energy level, which is based upon its period on the periodic table. Then we get into subshells. We talked about this in Unit 1. Subshells S, P, D, and F. Those are further broken down into orbitals. We'll look at this a little bit more extensively here in a minute. And then in a couple days we'll talk about upspin and downspin when we look at orbital notation. So we're going to try and get to here, talking about the subshells today. Tomorrow we'll start looking at orbitals and our electron configuration. And then the following day we'll look at our orbital notation. So we're going to narrow in on the specific atomic address. So let's talk first about our electron energy levels. You use N, right? That's the period that you're on. And the number of electrons that can fit within that shell is 2n squared. So if I'm in the first energy level, it would be 2 times 1 squared, or 2. If I'm in the second energy level, then it's 2 times 2 squared, so 2 times 4, or 8. Okay? So let's look at this so that we kind of understand what we're looking at here. And let me drag this down here. So I have my energy level, right? That's based off of the period. Within my energy level, I have a subshell. So my subshells within my second energy levels are the S and the P, right? And within my subshells, I can then break down even further into orbitals, a 2s, and then I have a 2px, a 2py, and a 2pz. Okay? And again, when we talk about orbitals, we're talking about that high probability region where we are likely to find the electron, right? That 95% region where the electron is located. So here's another image. It's a little blurry, but this is what it looks like more in its shapes, right? So as I add energy levels, they all sort of stack on top of each other. It's kind of an interesting image, not super important. But this sort of denotes my first energy level. My second energy level, I add the P subshell. My third energy level, I add the D subshell. If you are confused by this, go back to your Unit 1 notes when we talked about atomic history, and you can see a much clearer picture of these energy levels. Okay, so here are my subshells, right? These are my p subshells. So I have my 1s, my 2s, and my 3s subshell, and then I have my 2p and 3p subshell. Okay, we're going to go through the orbital shapes and the number of electrons that each one can hold. So if you don't recall, we have gone through this again, but we are going to go through it just one more time. So I have my s subshell. I have one orbital in my s subshell. And if you recall, each orbital holds 2 electrons. So here I have 2 electrons total. Here is the p subshell. Notice that I have 3 orbitals within my p subshell. 1, 2, 3. They actually all stack on top of each other. They're not separate like this. So my p orbital, my p subshell has 3 orbitals. Each orbital contains 2 electrons. Right, so I have 3 orbitals for 6 electrons total. Okay, it is dumbbell shaped. That's the language that I want you to use, is dumbbell shaped. Okay, my d orbital shape, let me move this back up here. So these are all 5 orbitals within the d subshell. Okay, so my d subshell has 5 orbitals for a total of 10 electrons. Okay, the easiest way to think of it is double dumbbells, and then here you have a donut. Okay, I'm not as concerned about you knowing the D shapes and the F shapes, but you do need to know S and P. So here is the F subshell. I've gone ahead and circled all 7 orbitals that belong to the F subshell. Remember, each orbital contains 2 electrons, so this gets me to a total of 14 electrons. So if we break this down, in my first energy level, I contain only the S subshell. In my second energy level, I contain my S and my P subshells. Third energy level contain S, P, and D. Fourth energy level, S, P, D, and F. Okay? I have S, P, D, and F from my 4th energy level through my 7th energy level. So within these subshells, right, my S has 1 orbital. In my 2nd energy level, my S subshell has 1 orbital, my P subshell has 3 orbitals, right? As I get to my 3rd energy level and I add the D subshell, I get 5 orbitals. And then with the F subshell, I get 7 orbitals. So my number of electrons goes from 2 to 2 plus 6, or 8. Right, 2 plus 6 plus 10, 18. And then 32. Okay. Now, here's what I want you guys to do next. There is a POGL that has been left for you that will introduce the concept of electron configurations. You will learn how to do electron configurations tomorrow. My expectation of you is for you to attempt the POGL. Electron configurations are not difficult. However, they do take a little bit of practice. It's one of those things where you have to do it a number of times before you get it, but once you get it, you can't unlearn it. Okay, so don't be discouraged if you're going through this POGL by yourself and you don't quite understand what you're looking at. It is okay. When Miss Gunter comes back tomorrow, you can go through that. Okay?